Welcome to the third and final video of the series. This video is meant to help you throughout the journey of the Kaggle competition to climb up the leaderboard using 3LC. Now that you have a baseline score, the question is how do you improve it? Remember, the model is fixed, it's YOLO V8 Nano, and you had to train it from scratch. So the lever that you have currently in your hand is data quality. In this video, I'll walk you through a few concrete strategies that you can use, a few dashboard workflows, and a powerful feature in 3LC for this competition is converting predictions to ground truth labels, which means you can use model feedback to improve your data quality by fixing flaws in it, such as missing labels, inaccurate labels, and all sorts of different flaws that it has. So let's head over to the most recent run that we had and open it up. Now, as you can see, there are a lot of options over here and there's a lot going on. Let me simplify a few things. On the top left, you can see we have the train and val set. For this, we need to fix the train set. So let's select that. And this is the run that we saw yesterday, which had a lot of metrics that were collected. So the key issue that we need to find out first is missing bounding boxes. Now, there are different ways in which you can do that. You can do that by taking the image column, the bounding box column, and the bounding box predicted column, create a 2D chart, and you will see something like this. So the dotted boxes that you see, these are the predictions that a model made, and the other boxes are the actual bounding boxes. Now what you can do here is you can set filters in a way which reduces all of these noisy bounding boxes, and you can do that by increasing the confidence level and just getting candidates which are really high confidence. So when you add these predictions to the train set, they are accurate. So if you would like to inspect these, you can just simply go ahead and use the keyboard keys that you have, so which is down, up, left and right, to iterate through these bounding boxes. So when I do that, these are the predictions that our model had made, and by the looks of it, there are a lot of candidates that fit the car better than the ground truth. And we can do this for a lot of images. And when we change the filters on the left hand side, we want to find out boxes that are missing boxes, right? So what we can do is we can reduce the IOU to 0. So what this essentially means is that the model is really confident that there is a vehicle in a certain location, but there is no overlap with the ground truth bounding box. So what this means is that we get these candidates over here where there was no label and no bounding box for this vehicle, and our model predicted correctly. So you can use this prediction to add that by right clicking and accepting the selected prediction or pressing M on your keyboard. And once you do that, your prediction will be added, and once you keep doing this over and over again, let's go ahead and select the second image. You see here there is a vehicle, it's a car. Yes, it looks like a car. If you press M on the keyboard, it is accepted, and you just keep doing it over and over again. Now this can be a little tiring because if you had to do this manually, it will take a long time going through each and every bounding box. So if you are fairly confident in the filters that you've set, so in our case we can clearly see that the predictions that the model is making, which is more than 0.842 confidence, we can try to batch assign these labels and predicted bounding boxes to the actual training set. And how we can do that is, let's go ahead and first press Ctrl and B, and we come up to this specific window. Now this window is quite important when you're batch assigning. When you select all rows, it will batch over the whole data set. So it is subject to filters on predictions first, but then it will go over all of the examples that you have selected. If you just select this option, which is selected row, it will just select this specific row in which you made the edit, which is one bounding box that's present. And then when we select the last option, it is only for the bounding boxes that we have selected. So this matching criteria that you see here and this slider, it is just so that when a prediction and a ground truth box match if overlap is above the specific value. And when we move over to the preview of the results, you can see these 3 tick boxes or check boxes. And the first checkbox add for this one, for the unmatched predicted bounding boxes, is that you add these as new ground truth boxes. For the second option, you replace the ground truth with the matching predictions. It's typically for tighter boxes. And the final one is the unmatched ground truth bounding boxes. If unchecked, the ground truth boxes are deleted. And the final option that you see over here is if you want to assign a class to all of the boxes predicted, you can do that by checking this box and assigning any vehicle to it. In our case, we won't, because we don't know what the classes actually are, but we know that the bounding boxes are correct and the classes are correct. So what we can do is we can simply go ahead and accept the predictions, and that will add it over here in the commit pending edits. And when we make these edits, our new table revision will be created. So the next thing that I wanted to cover was the workflows window. Now this is really important, because let's assume that you had to do all of these things, right? You had to create a 2D chart with the bounding boxes and the predicted bounding boxes. But if you wanted to avoid that hassle, you have this wand symbol over here, which you can click, and it will give you a lot of option of the available workflows that you can use to your advantage. For example, so as we were doing missing labels, we can start this specific workflow, and it will create this view for you where you can use it to compare. So for example, it already set the confidence to 0.07. You can increase or decrease this depending on how many candidate bounding boxes you want. Let's say, for example, if you reduce this bar, you'll get more candidate missing boxes, and if you just put it higher, then you'll get lesser and lesser. So this is the default, and let's go ahead and check if this is correct. And as you can see, till now most of the predicted bounding box seem to be correct, and of the correct class as well. And let's say if you're happy, you can see we have 496 candidates that we have selected out of the 8,834 images that we have. And if we are happy with this, what we can do is that for making sure that we are selecting the correct bounding boxes, you can bump it up to, let's say, for example, 0.8. Go through a few more, just to make sure that you are selecting the correct predictions. And once you are happy with the majority being true, you can just bulk assign them by again pressing Ctrl plus B on your keyboard, and then you can just accept all of these predictions, and all of these will be accepted, and then you can commit the revision and you can move on to the next steps. The second thing that I wanted to show you is the inaccurate labels workflow. So this workflow will help you find the bounding boxes that are misaligned, so that are not a good fit. So for example, in this case, let's take a look at this bounding box. So this prediction, so as you can clearly see, the right prediction fits the car better than the ground truth. Let's head over to a few more examples. Here you can see the same is the case. Here it's debatable, so you can try to increase the confidence and get much better candidates. Here that is the case. So I mean, we just have 2 candidates, but if you want more candidates, you can always slide this window back. I would suggest that you use this workflow towards the end, because missing boxes is a bigger deal than misaligned boxes. So this is how you can do that. And again, if you want to bulk assign them, you can just use the batch assigning tool and you can commit the pending edits. Finally, I'd like to brush up over a few more things. You can see that we have, let's get rid of these views, and you can see there's a embeddings column over here, and you are wondering why that is and how we can use that. You can simply create a 3D chart with these embeddings, and you'll see a lot of these tiny boxes. Let's reset our filters over here. You can see a lot of these dots, and these are embeddings that were collected during training. and you can see there's a lot of separation. You can see a lot of different clusters in different areas. So my guess is that these would be different scenes in the data set. So let's go ahead and inspect them. For example, let's go ahead and check out this cluster, and to know if that's the case, let's go ahead and just see if that's correct. So yeah, this is one. This is, I think this probably might belong to the same video sequence, and that is correct. If you can see, if there are a lot of bounding box predictions, you can just bump up the confidence to get accurate ones. Let's go ahead and select this specific cluster, and yes, this is a different scene. Let's go ahead and let's select this cluster, and yes, again this is a different scene. And what you can do with embeddings, what I would recommend to do towards the end is, let's reset all the filters. And what you can do is you can color the embeddings using confidence. So for example, if you drag over the confidence bar over here where it is written training phase, you can color your embeddings using confidence. And let's switch back to the pan or rotate tool, and let's find out the images in which our model has struggled to predict bounding boxes in these scenes. So for example, in all of these scenes, let's use the lasso tool to boil down the candidates. And let's see, so these are the images where our model is really struggling to make predictions on and get good results. It's really unconfident. So if you're able to fix these issues, because you can clearly see there are a lot of false positives, this will result into the model being robust in a lot of these scenarios. So let's say if you fix the low confidence images, the model can then learn to easily identify such scenarios in different video sequences, and you can do this for different video sequences that you have, these different clusters. What you can do is that you can again go back to these images, and then once you have labeled them correctly, you can try to increase their weight. So what that means is, this weight column, it is there so that you can show specific samples to your model more times than the other, so that it learns them better. Let me go ahead and grab the lasso tool. Let's select this scenario for example. Then you can select the weight column and all of the candidates. You can either select this or press A on your keyboard, and you can change the weight from 1 to, let's say, 1.2 and commit the edits. And what this will do is that it will tell the model to take a look at these specific examples more than the other examples by 0.2. Now what that correlates to, you can go ahead and take a look in our docs. You can do a lot of things with the dashboard. You can derive a lot of columns, or you can have the workflows do it for you. This is the power of the workflows. I won't give out too much information because this is a 2-month competition. So I hope that you go through the documentation whenever you're stuck in something, or come back to the videos. I would highly recommend that you go through this end-to-end example that our teammate has put up, and it is a similar case. It's object detection. It will teach you through all of the small details that he used to fix the errors, the labeling errors that were there. And if you do have any other questions that you would like to ask us, please head over to the discussions tab or either on our Discord. We will be available, and if we see a lot of queries, I will also host a few office hours on Discord. We can do that on Discord or on Zoom. And let me give you a summary of the strategies that we saw today. So first, we saw missing labels. So we can batch accept high confidence false positives. So that will give you like a really good MAP impact. Then you can also find out wrong classes. You can filter for high IOU false positives with high confidence. And these are easy fixes, and you'll get a direct MAP gain with that. You can find incorrect bounding boxes. So using the workflow that I showed you, you can potentially find duplicate bounding boxes. And finally, you can also use embeddings to find out where your model struggles, which samples your model struggles on, and try to weight them up as you go. You can use a mix of all of these techniques, but I highly recommend that you go systematically. It's about how you use the model's feedback to improve the data quality to see massive improvements in the MAP on Kaggle. For this competition, the leaderboard rewards the person who is most systematic about data quality, not the luckiest or the fastest. You have to be really thorough. Good luck, and may the best data win.